So friends, here you can see that in the last lecture we understood what is homogeneous partial differential equation, and we have seen what are the different cases based on the nature of the roots. Nature of the roots. Okay. So we will consider different cases based on the nature of the roots. Okay. Suppose when roots are real and unequal. When the roots are real and unequal, suppose we suppose that the roots of the roots are say m1, m2, m3. We consider only 3 roots by considering that it is given third order PDE. Okay. You can go for further higher order also. We can write out the same kind of solution. So in this case, we will write down the CF as, it is very simple. Phi 1 y plus m1x plus phi 2 y plus m2x plus phi 3 y plus m3x. So in the bracket, everywhere you will have to put a solution in the form of y plus mx, and m is replaced by m1, m2, m3. Here, as in the last solution, we were in the ordinary differential equation solution, we were adding C1, C2, C3 as arbitrary constants. But you no need to add arbitrary constants because phi 1, phi 2, phi 3 are considered as arbitrary functions. Here we are not writing as constants but arbitrary functions because we have considered them into the form of function. Okay. So the solution is very easy to write down when the roots are real and unequal. Okay. Let us see suppose of one example. Suppose we are given the equation solve r equal to a square t. So you don't afraid, don't get frustrated. You just look at the equation, how the equation is given. The equation is given in the form of r equal to a square t. So if you are confusing with these symbols, then write down this into the original form. The equation is del square z by del xl because we have noted r equal to del square z by del xl. Then if this term we take on left hand side, r square, and t is del square z by del y square, and on right hand side it is 0. So this is already homogeneous partial differential equation because all the derivatives are of second order. Okay, and it is also linear. Okay, because no other function is involved. Z is multiplied with this, and the right hand side is 0. So on right hand side we are not given any function. So only we need to find out CF, and here as I told you that when right hand side itself is 0, then CF itself is the solution. CF itself is the solution. So we rewrite the equation. Actually, if you don't write the steps which I am writing, then also it will do. But for your convenience and for your understanding in a better way, we will use the symbols. Here we will write down d square for this, minus a square d dash square for with respect to y, z is common equal to 0. Okay. Therefore, our auxiliary equation, simply write down auxiliary equation. Here you use colon. Okay. D for m and d dash for 1. Okay. So m square minus a square equals 0. This implies that the two roots are possible. M square equal to a square. That is m equal to plus or minus a. That means two roots are there. One root is a and second root is minus a. You can see. Okay. If it is second order, then two roots will be there. If it is third order, then three roots will be there. So you note down the number of roots also. So here we can see that both the roots are real and both are unequal. That means they are not equal. Okay. A and minus a both are different. So this is our M1 and this is our M2. Therefore, the solution is simply z equal. Here we will not write CF because CF itself is the solution, because no need to find out particular integral over here. So this is nothing but phi1 y plus ax. This is the first one, and second is phi2 y minus ax. So this is the solution, and here you should write down that where phi1 and phi2 are arbitrary functions. Okay, so this is the complete solution, and you can get 3 to 4 marks directly, very simply. Okay, have you understood this one? And friends, you also write down simultaneously with me. So if you will continue writing with me, then you will get a good practice and you will understand the solution process very easily. Okay, are you clear with this? So I suppose that you must have been clear with this. Okay, then we go for second type. Second type, when the roots are real and equal. So if the example, friends, here you note that right hand side with right hand side 0, also the example based on right hand side equal to 0 is being asked in your examination of 3 to 4 marks, and it is very simple for you to get the marks. Okay. So now, we suppose that the roots are equal. Two roots are there for second order differential equation. These are m1, m1. I suppose we consider third order differential equation. m2 is unequal. So here you can see that the two roots are equal. So in ordinary differential equation, what were we doing? c1 plus c2x e raised to m1x we were writing now. And for third is unequal, so we simply write down this as c3 e raised to m2x. So this is the basic thing. So here also we will write down the solution or CF, because here we are obtaining first part. So this part is obtained as y phi1 y m1x. Very simple. It is very simple. Phi1 y plus m1x plus for second one also phi2 y plus m1x. But both are simple, so it will get same. So here we need to multiply this by x. So here you must note down this. This is the only difference, and this is the different solution, unequal solution. So for this we will write down phi3 y plus m3x. So this is the solution. You can see, very easy to write down. Okay. So now let us see one example based of this type. Suppose we are given the example is d cube minus 4d square d dash plus 4d d dash square into z equal to 0. So here you can note that the solution given here is the equation given here is in which right hand side equal to 0. So in this case, our complementary function itself is the solution. No need to find out particular integral. So this kind of example may also be asked in your examination. So we will find out its solution. For solution, here if you want, you can write down for the cube, del cube by del x cube. For d square into d dash means del cube. The higher derivative, complete derivative is third order derivative, because it is second derivative, it is first derivative. It is d dash, not 1. So d square means with x square, 2 times with x and 1 time with y. Then d dash square means del cube is there, because 3, the order is 3, 1 plus 2, 3. The single derivative with respect to x and double derivative with respect to y. So del y square. You don't write this as del y whole square. This is not proper. Del y square. Okay. So we don't want to write down. We can write down auxiliary equation right directly. So we will put m for d and 1 for d dash. So this is very easy. So m cube minus 4m square plus 4m, it is 1. And don't write z. Don't write z because by mistakenly or in hurry, when you are in hurry, then by mistakenly you may write z, but this is not proper. Now it is only required to find out its root. So here we can see that m will be common. So this is m square minus 4m plus 4 equal to 0. Okay. Therefore, its factors are m minus 2 whole square equal to 0. Therefore, we have the roots are 0 for this, m equal to 0, and 2 and 2 times m equal to 2, but it is 2 times because square is there. So there are 3 roots because it is third order differential equation. And here you can see that it is homogeneous because its order is 3, its order is 3, its order is 3. So order of derivative in each term is same. So it is homogeneous. So here you can see that therefore the solution is z equal to, this is different solution. So we will write down this as phi 1 y plus mx. You must remember this form, y plus mx. M equal to 0, so only y is there. And here you can see that the 2 roots are repeated. So for second root, solution is written as y plus mx, that is 2x. Okay. Phi 1 is used, so we start now for y2. And third, we write for phi 3. Here the same roots are there, so we will multiply this by x. Only need to multiply this by x, y plus 2x. Okay, so this is the solution, and you should write down that where phi 1, phi 2, phi 3 are arbitrary functions. Okay. Suppose if one more root is there, that is 3 roots are there, then nothing is difficult. You multiply the second one by x there, x then x there, and write down phi 4 y plus 2x. So you can get the solution in this type. If more repeated roots are there, then you multiply this by x, x square, x cube, and so on. Okay. So this is the solution. Then let us see the third part. When in the third part, let us see when the roots are imaginary. Okay. When the roots are imaginary, then also the solution is very easy to write down. Okay. And this solution can be written as, actually, as per this procedure, the solutions may be appear in this form. Suppose one root is there, it is of the form a plus or minus ib, and I told you that imaginary roots always occurs in pairs, a plus ib and a minus ib. So by using this fact, we can write down this solution as CF equal to phi 1 y plus m1x, because here m1 is a plus ib and m2 equal to a minus ib. So you can also write this as y plus a plus ib into x plus phi 2 y plus a minus ib into x. Okay. So in this form also you can write down the solution when the roots are imaginary. Okay. And you can put more simplification if you want, because this part can be written as y plus ax plus ibx, and this you can write as y plus ax minus ibx. So this you can assume as capital X, and this you can assume as capital Y. That is capital X equal to y plus ax and capital Y equal to bx. Okay. And this second solution will become x minus iy. So you can also write down the solution into this form. But it is simply to write down the solution into this form. Now let us see more examples based on the 3 cases. Okay. Actually, if you use this symbol, then CF can be written as 1/2 phi 1 capital Y plus I x plus IY, sorry, capital X, because we have assumed first one as x plus IY plus phi 2 phi 1 capital X minus IY, then plus 1/2 into I. Here I need to multiply phi 2 capital X minus I capital Y plus phi 2 plus Y and phi 2 capital X minus capital Y, where we have noted that capital X equal to Y plus AX and capital Y equal to 3x. Okay, in this way also you can write down, because if we simplify that form, then we can obtain this kind of solution. Now let us see more examples. One example let us see, very simple example, which was asked in examination also, that we solve. Very simple. Del cube z by del x cube equal to 0. So here you can see that only one derivative we use, and it is of third order, so no other derivatives are there. So we can consider this as homogeneous partial differential equation. So solution as a part, we can have auxiliary equation is m cube, because it is nothing but del cube, d cube z equal to 0. So m cube equal to 0. Z we don't write. So it's two. There are three roots of this one, and all are same, 0, 0, 0. So solution is written as z equal to first 4 1 phi 1 y plus m1x, but all m1, m2 and m3 are 0. So phi 1 all are repeated. So x we multiply by x, phi 2 y, plus then again we multiply this by x square, phi 3 y. So this is the final solution, and then write down that where phi 1, phi 2 and phi 3 are arbitrary functions. Okay. Now let us see another example. Solve del cube z by del x cube minus 3 del cube z by del x square del y plus 2 del cube z by del y cube equal to 0. So this is again auxiliary form of the homogeneous equation. Okay, because right hand side is given 0. So we don't require to write down CF, simply we can write down Z there. So solution. First of all, we put this equation, given equation is this d cube minus it is d square into d dash plus 2 d dash cube into z equal to 0. And therefore our auxiliary equation will become now m cube minus 3m square plus 2 only equal to 0. M cube minus 3m square plus 2 equal to 0. And it is a third order polynomial. So there will be three different roots. Actually it cannot be solvable directly. So first solution can be obtained by making suitable substitutions. Suppose if we put m equal to 1, if it is getting 0, then we can say that m equal to 1 is the root. So if we put m equal to 1 minus 3 plus 2, yes, it is 0. M equal to 1, make it is 0. So m minus 1 is the root factor, one factor. So m minus 1 is one factor. Then we will adjust the terms. Here m cube required, m is there, so we will multiply this by m square. So we will get m cube. Okay. Then we will have minus m square, but here is minus 3m square. So minus 2 is required. So minus 2m is there, so minus 2m square we are getting. And plus 2m, but 2m is not here. So we will have to completely cancel this term. So we will multiply this by 2. So 2m is there. So minus 2m plus 2m will become 0. And then minus 2. Okay. sorry, here m square minus 2m. Minus 2m is plus 2m. So here we need to put minus 2. Yes. So minus 2m and plus 2m. It is plus 2m. Minus 2m is 0. So plus 2. Because whenever we factorize this, then this last term must come over here. So here plus 2 is there. So it is over. So m equal to 1 is the root from this. We cannot factorize this directly. So we will make the use of minus b plus or minus root b square minus 4ac divided by 2a. Okay. This is for ax square plus bx plus c. So minus b means 2 plus or minus root b square. B square means 4 minus 4ac. Minus 4a is 1 and c is minus 2. So plus 8 divided by 2a. 2 into 1. So 2 will be cancelled here. So it will become plus or minus 1. And the 8 plus 4 is 12. 12 is what? 2 root 3. 2 root 3 means 2 will be cancelled. So 1 plus or minus root 3. So this is not imaginary. You can see it is real root. That means here m1 is 1 plus root 3 and m2 equal to 1 minus root 3. If imaginary root is there, then we need to use the case 3. So here the solution we can write as z equal to phi 1 y plus m1x. m1 is 1 plus root 3 x plus phi 2 y plus m2x. That means 1 minus root 3 x. So this is our solution, where phi 1 and phi 2 are arbitrary functions. So you can see the solution is very easy in this case. Okay. Now let us see another example. Suppose, are you clear with this? Let us see another example. Suppose we are given solve 2r plus 5s plus 2t equal to 0. Okay. So we will solve this equation now. Have you noted this? You note down this. Okay, I suppose that you have noted this. So now this equation is nothing but 2d square. R is d square. Phi s is d into d dash, and t is d dash square into z equal to 0. And therefore auxiliary equation is 2m square plus 5m plus 2 equal to 0. So friends, you solve yourself. It has the two roots, minus 1/2 and minus 2. One is m1 and second is m2, and you can write down the solution. Okay. Thank you. Next time we will see another part of finding particular